Here are two links that help you understand it better.
Welcome to Power Protection Products, Inc. And today we are going to talk about power quality explained, specifically power factor correction. My name is Andy Engrich with Power Protection Products, and today I'd like to go over a topic known as power factor correction and power factor correction solutions. Up here on the board we have power factor, and this is also known as the power factor triangle. Down here you would see this line which represents kW, known as real working energy, also known as watts. On this side of the triangle, this line represents kVAR, also known as reactive energy, to build up magnetic fields. Now this line over here represents kVA. This is total power. And this is the combination of kVAR and kW. And down here, the cosine of this angle is where we derive mathematically power factor. Now to help me further explain power factor and reactive energy, we have a little drawing down here, and what this represents is a piece of wire, maybe in an electrical industrial facility, and this wire, you can see these rings around, that represents magnetic fields. Before current will flow down this conductor to a motor or some other electrical device, magnetic fields have to be developed around all those current carrying conductors. Currently, this real energy is being provided by the electrical utility. And now I'd like to show you in a live demonstration how this works. Now up here on this board, what we have here is two inductive motors, similar to what you might see in an industrial application. And above those on this board are different capacitors of different kVAR values, also tied to switches that we can manually operate through this live demonstration. And then over here to the right, what we have is a power quality meter that can measure and document all of these kVAR, kVA, and kW demands. So now what I'd like to do is turn on one of these motors and show you what the actual power factor is. So as we bring on the first motor load, you can see as we zoom in, the total power factor is 0.225. And now, as I would like to correct this power factor, I will start to begin bringing on some capacitors, flipping on the first stage. Now that we have done that, you can see we've brought our power factor up with a minor improvement to 0.294. We still need to correct even further, so we'll engage another stage, and you can see that the power factor is now corrected to a 0.958. Very close to unity, where what we'd also consider as a perfect scenario. I will now bring on the last stage, and you can see we went from an inductive power factor or lagging power factor to a leading, also known as capacitive power factor. And we are injecting more kVARs than we're actually consuming. I will now bring on the second motor to show you we can bring down the power factor again with another inductive load, a 0.60. Now, this demonstration shows you by correcting your power factor with power factor correction capacitors, you can alleviate and eliminate the reactive demand measured in kVAR. If you'd like to learn more about this, please visit us at www.powerqualityuniversity.com.